Good morning to you students, wherever you are. This morning we'll be having your usual basic technology on the topic basic electronic devices. We have talked about troubleshooting. You will recall we discussed troubleshooting in our last class. We talked about how troubleshooting is done, and then we talked about some electronics that require troubleshooting. Today we are going to look at the components of these electronics and how things are carried out in these components. While we are moving forward, or before we go in detail, we need to, as usual, look at the objectives of this lesson. Call it the learning objectives. That is, at the end of this lesson, students should be able to define semiconductor, state 4 types of emission, define and state the uses of a diode, then list 6 electronic devices. We now go to the content, which is basic emission. When you say emission, it means release, set free, let it go. There are many words you can use for that particular word, emission. Basic emission is the liberation. The word liberation means set free, let it go of electron in semiconductors. This liberation we are talking about is to release electron from a semiconductor or an electronic devices. It must be done before the element or that particular device can perform 1 or 2 required functions. Just like human beings not feeling well, that human being will not be able to do 1 or 2 things that is required to be, even your phone or laptop. So there are things that must be removed from there. If it is a virus, it must be deleted. Just also electrons in these devices are meant to be set free for that particular device to perform 1 or 2 functions assigned to it. We now look at semiconductor or metalloid. It is the same thing, just as we said, recall in our last class, we said troubleshooting also means fault detection. Semiconductors are elements with properties in between metals and non-metals, or properties in between, or the mixture of those of metal and those of non-metals. Just like somebody having characteristics or some elements or some behaviors of a father, are you as a student having some behaviors, some things that probably your father always sits to watch TV in the evening. You're having that kind of also attitude that you copied from your father. You also have another one that you copied from your mother. Probably your mother wakes up very early in the morning and your father wakes up late, but you have copied this one from your mother. So very early in the morning you wake up, and every evening you also sit to watch TV. You have copied some from your father. You have the properties of the dad and properties of the mom. That is the mixture we're talking about. That is in between. You know what non-conductors are, or non-metals are. The non-metals do not conduct electricity. That's one of the properties we have discussed, metals and non-metals in first and second term. The 6 elements commonly or we call or regard as semiconductors or metalloid are boron, silica, germanium, arsenic, antimony. This is not antimony, 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 and tellurium. Tellurium. Please, this is not antimony, antimony. This is not an antimony that you call antimony. So there's a way you pronounce this. Then we have how you emit electrons from these particular metalloids or the semiconductors we're talking about. Some fact or some things must be considered in your mind. That is, external energy or force that is greater than the one binding them is required. If you have two people holding themselves chained together, then you want to separate the two. You have the force holding them is big, and then you need a bigger one, because if the power, two of them join their power together and it's greater than yours, you will not be able to separate them because they are holding themselves. But when your power is greater than the power of the two of them, you separate them. So the power required to remove it should be greater than the force binding them, that's holding them together. That's what I mean. Another one is the energy must be obtained from light, sun, or any other place in a field. We will talk about that later. The energy, how it comes. It could be the sun that hits that particular thing, then the electron is emitted. That's what we mean by that. Then lastly, the external energy that is used to bombard the conductor, thereby setting the electron free, is also required. You need that. That's what we mean by that. Then the next thing is the types of emission. We have the thermionic primary emission. It is also called primary emission. That is the use of heat to liberate electrons. That is the meaning of that. When heat is used, like this thermo, the word thermo means heat. So when heat is used to liberate electron, it is called thermionic emission. Then photoelectronic emission. This one is use of light. Photo means light. So the liberation of electron from electronic device or an element is with the use of light is the photoelectronic emission. Then another one is the cathode or cold cathode emission. You use energy that is stored in magnetic or electric field. We have discussed magnetism. I spoke about magnetism and electricity in our first term work. Then lastly, we have the secondary emission, the use of kinetic energy. We were taught types of energy, the mechanical and the mechanical potential and so on, types of energy. And some calculations were done too in your previous terms. So using kinetic energy to emit free electron from a conductor, a metal, is called the secondary emission. Secondary is different from the primary. The primary is the use of heat, that is thermionic emission. The photoelectronic is the word photo, light. That is what we mean by that. We now look at, these are the types of emission. These are what you are saying. These are electrons that are being emitted. You see this going off, going off. That is the meaning of this arrow. These are electrons that are being emitted from this particular electronic device going on. We have very many of them. These are being going off. You see there, emitted electron. That's the meaning of this one. Going off, going off, going off. It could be this is light. The light is shining. You see the light. There are different types of emission, as I've explained. But there's light shining on this place from here, and so making the electrons to be emitted. It could be by the use of microscope. You may not see them with your eyes as it's going on. Use a microscope in a lab or whatever place you want to use. You will be able to see the emission we're talking about. Then we look at basic electronic devices. Let us see these electronic devices we're talking about. We said in our objectives that we should be able to list some of them. They are devices that can control and amplify the word, that's enlarge the flow of electron in a circuit. You were also taught circuit, a closed path or a path through which a current, electric current flows. You were taught that in your previous term. So the one that enlarges or amplifies or controls the flow of electron in that circuit is the basic electronic devices we are talking about. Examples are the resistor, capacitor, the diode, the triode, the transistor, gas discharge tube, and so many others. We will look at maybe one or two of them, particularly the diode. before we cannot go on to other examples or other devices, other basic electronic devices like the gas discharge tube, the transistor, the resistor, and so many others. We will take, first of all, let's start from the diode as we go on. The diode is used to rectify or used as rectifier. When you say rectifier, it means to rectify. That is what it's used for in as an element in electronic. It has two electrodes. Just like you have your mouth, this is the place food comes in. Then the anodes, or whatever you call it biologically, the place the waste, the food that has been used by the body goes out of your body. So also the anode, the diode has two electrodes. One is called the anode. This anode is the one that collects the electron, and then cathode is the one that emits the electron. The anode sends and the cathode release. That is the diode itself. It has two electrodes. From the word di, it means diode. What does the diode do? Diode, from what we have discussed, this is a diode. I will come back to the functions. Let's look at the diode. Positive, just like you have your battery. You know your batteries? You have what, two eyes, one and one. One is written plus and the other one is written minus. That is positive and negative. You have your battery, you see one at one end, you have plus, at the other end, you have minus. That's the positive and negative. So also the diode has, as an electronic device, that's positive charge proton, and then the other side. It has the anode and the cathode. That is what we are talking about. This is the cathode. These are the emitted electrons that are going out. It has a metal, this got a glass or metal envelope. That is, this metal envelope is the one that covers the thing, just like you call it a case. The one that covers it, that is the case. This is the cathode plate, electron producer, the one that produces it. Then this is the electron, emitted electron, and then electron catcher is the anode that receives. That's what I told you in the definition or the definition of anode or the pass of, sorry, the definition of diode or the pass of diode. The electron catcher, that's the anode, is the receiver. Then the electron producer is the cathode. That is the cathode plate. The electron producer, one produces, one receives. Then this is the emission of the electron. These are the electrons that are being emitted. When we meet practically, like we do most times in the basic technology workshop, we shall be looking at, I will dismantle some of these things for you to see the inside yourself with your eyes. That's what I would. Then let's look at the functions of diode. What does it do? I have told you it's a rectifier. In converting AC to DC, that is alternating current to direct current. We have talked about electricity in also your previous terms. In converting alternating current to direct current. Also, it is used when necessary for alternating current to flow in one direction in electronics, not go back and go front, just to flow in one direction. It is the diode is also used to control that. Therefore, the diode serves as switch in electronics. You can call it switch. That is switch. You stop the movement backward and let it be going. You can switch it to be going forward and backward or just forward. That is what we mean by being a switch. When the polarity of battery diode is such that is when the battery is fixed in a way that current are allowed or electrons are allowed to flow through the diode to be going, then the diode is said to be forward biased. When it is blocked, the current is not allowed to flow to be going again. It is called reversed bias. We have the forward bias and the reverse bias diode. If you place N-type or N silicon and P silicon, if you place them, the two of them side by side, they will form a diode. How do they do this? That is, the excess electron or the current in the N type attracts the excess hole in the P type. When we are talking about N and the P, we are talking about the negative type and the positive type. I will show to you in your week 4 work what we mean by N-type junction and P-type junction, while we go into triode and others. So it means the negative type and positive type coming together and they form the diode. This is what they form is called the P-N junction. The P-N junction is the positive negative junction, two of them merging together. That is what we mean. We have the positive, like I've told you in the battery, you have the P, that is the plus. Then you have the N, that is just the dash at the, there's a way it is written, just dash there at the other side of the battery. This is a diode I was explaining to you, the electron producer and then electron catcher. The anode that catches, the cathode that produces. Please do not forget the diode has two electrodes. What we call them are electrodes. That is the anode and the cathode. That is what they are called, the electrodes. We will have to quickly have a recap of what we have discussed. I have said that electronic basic emission is the release of electron from an electronic element or device. We have talked about the types of emission, the primary or thermionic use of heat. We have talked about the photoelectronic emission, the photoelectric emission by the use of the word photo, light, use of light. Could be sunlight, could be, the one that is primary or thermionic could be also be heat from the sun, could be the sun, so it could be the heat, but it is heat. Then the other ones, we talk about the cold cathode, and then we'll talk about the secondary emission. We've also talked about these devices. We are talking about, that's metalloid. We said that's semiconductor or metalloid. We said they have the properties in between non-metals and metal. They possess the property, some of metal, some of non-metal. They are in between. They are not really non-metals. They are not really metals. We talked about the basic electronic devices, the diode, the triode, and then we looked at diode critically. We talked about the parts where we've seen the electrode, we've seen the types of electrode, that is the anode electron catcher, and then the cathode electron producer. We've also talked about what it is used for. This is where we end your week 3 lesson for this term. We will now quickly look at week 4 lesson. Your week 3 lesson was what we discussed before now. We now look at the week 4 lesson. Week 4 lesson is talking about continuation, or the basic electronic devices continuing. Where we stopped on diode, we now look at others, like the triode, the resistor, the capacitor, and so others. That's what we now look at in your week 4. Before we will also go in detail, we need to have a view or sharing of the objectives for the lesson as usual. That is, at the end of the lesson, you should be able to mention and identify components of electronic devices. Precisely, we're talking about the remaining ones now. Then measure the use of components of electronic devices. These are the objectives for this week 4 topic. That's the continuation of the other one. Then we now start from triode. You also recall that in your week 3, we talked about die. The word die is what you say, die, is 2. Diode means 2. We're talking about 2 electrodes. Now, this is tri. From the word tri, it is 3. So triode is a vacuum tube with 3 electrodes. It is used to amplify, that is to enlarge or control the electrons. The parts of the triode, just like the anode, their parts are a bit similar. We have the anode, just like the diode, like we discussed, it receives the electron from the cathode. Then the cathode is the electron, the one that emits the electron on the device. Then there's another part called the grid. This one regulates the flow of electron from the cathode to the anode, because cathode is the one that releases and the anode is the one that catches. So it is the grid that regulates the leaving or the flow or the movement of the electron from the cathode that is being going to the anode to be received. This grid has another name called the valve or the triode valve. That is about the triode. Remember 3 electrodes. The cathode, electron producer. I've discussed with you and I've shown you electron on the diode. Electron producer, then the grid, the one that controls how it moves, just like your system. When you eat too much, your food that is supposed to take per day, that your human body is supposed to absorb, has a limit. Or, for example, water. You drink water, your stomach will be absorbing it. It will get to a stage when you put water in your mouth, it comes from your mouth. But your stomach will be the one to tell you, stop taking water. You should know that you are tired. You will not take water again, you stop. That is the control of the amount of water that comes into your body. If you pour water again, you will not be able to drink it. That is the work of the grid or the triode valve. This one was not found in the diode. That is one of the things you also note. Then this is the triode. It looks like the diode, but we do not see grid. Perforated plate. That grid was not in the diode, just like I've told you. This is the anode collector of electron, the one that receives. Just like in case of diode, this is the cathode, the electron emitter, the one that emits or gives or producer. That's the other name. This is heater, where the source of heat comes, or the source of heat. Before electron can be emitted, we have said there must be a source of heat and other things that we discussed before. Then we need to look at we talked about the PN and NP. This is what we mean by the PN. In terms of when we're discussing the diode, we talked about PN, positive and negative, and then negative and positive. Then forms what we call a PN junction. This is the positive, this is the hole. And I said negative comes in contact with the positive hole, gives you the PN junction. That is what we're having here. This is the negative, and this is the positive hole. This is the negative. This is the positive. This PNP, that is positive, negative, positive. Then negative, positive, negative. That's just a different. PNP and NPN. Negative, they emit. The P, they are team based. Then the other one here, N, they collect. That is what you are saying in the four. I come again. This one, the N here, they emit, they release the electron. Then P is the team base. They are saying here. Then the other N here, they collect. They are the collectors of the electron. That's what you have here. We also look at the symbol. This one is called, when we say team base, that's the base. Emitter, the base, and the collector. This is the symbol that are used for them. We call it the team base. Emitter, the one that is releasing the base, and the one collecting. Then this is emitter, the base, and collector. You can see there are two different ways of presenting these things you are seeing in the symbols. This one, the arrow is going out this way. Why this one, the arrow is going out this way? Please take note of what I have just said. Then we look at the transistor. Is another example of these devices. Is a small electronic widely used as audio frequency amplifier. We have said the triode is used to amplify. This one too is also used to amplify. But you know the difference between video and audio. What I am doing now is video. But in case of this one, we talked about audio, like the radio. It consists of 3 electrodes, just like the triode, emitter, base, or the grid, and then and then the collector, just like the triode. They are available in 2 types: the PNP junction transistor, just like we have discussed now. PNP, then NPN, negative, positive, negative, positive, negative, positive. In either case, emitter electron giver, that's the one that releases, is at the beginning, or base is at the beginning. Then the base, that is, the emitter is always, in either case, the emitter is always at the beginning, the base is at the middle, then the collector is at the end. That is what we are discussing on transistor there, just like this. The emitter here too is at the beginning, the base is at the middle, and the collector is at the end. That is what I mean by this. In either case, they are arranged in such a way. And the arrangement that is forward biased is called emitter transistor, while the one that is reverse biased is called collector transistor. We have also discussed that in terms of the diode. Forward biased, then backward or reverse biased. But this one, there's a difference. The reverse bias is the one that is the arrangement that is collecting, or the arrangement that is reverse is the one that collects the electron. That's a collector transistor. The one that allows it to come back is the collector. That is in case of the transistor we're talking about there. The forward bias is the one that allows it to go. Then the one that allows it to come back is, or reverse, is the reverse, or collect, get, is the reverse bias. We have talked about the forward bias in terms of a diode. Then we look at the gas discharge tube. It's another example because we listed them in our week 3 work. Talk about the transistor, resistor, gas discharge tube. We talk about the diode, the triode. This is, we're looking at the gas discharge tube. It is applicable for fluorescent tube. We have seen fluorescent tube that we use in our houses, even we have it in school. It absorbs less energy than filament tube. The energy that is being consumed by the olden days bulb is different from this. I will show to you the gas discharge tube. Then another one is the halogen lamp. This one is very bright. You see them, I think we have it at the door. We have it at the door. We have some in some of offices there. And you see them just like some people put it outside that door like street light. That's what we call the halogen lamp. It's very bright, filled with mixture of inert gases. You were taught this in chemistry, and small halogen. Inert gases and halogen mixed with it. It is very, very bright. This is a gas discharge tube. It looks like the triode. It has the anode, but this one has 4 things compared to the anode, the triode now. This one has the anode, the cathode, the grid, and the gas molecule. There are things that are filled in it. That is the gas itself. Though it has 3 electrodes, the gas molecule is added. The anode, the cathode, they do the same thing, just as they do in triode and diode. Then the grid controls the leaving or the flow of electron from the cathode to be received at the anode. That is the work of the grid, remember. But the gas molecule is filled inside. Remember, this is a plate. It could be a metal plate or any perforated any other plate that is used. That is the container, that's the outside of it. Then we need to also look at the resistor and capacitor. There are other types of, or the examples of electronic devices too that should be treated in this way for. Resistor, they are devices that are used to reduce or oppose. From the word you hear resist. When you say resist this person, it means what is if he's pushing you this way, you to pull yourself this way. You don't allow what he wants you to do to happen. That is the resistance or resistance. So we say resistor, they oppose the flow of electron in electric circuit. Then that's what they do. Then we have the capacitor. They are used to store current in form of electric charge. The capacitor is capable of holding the current, even when the alternating current AC is switched off. What we mean is that these days you have, let me quickly talk about the capacitor. You all have the charger, what do you call it, a rechargeable lantern or torch light in your house. There are capacitors there that are put inside. They look black or whatever color. What they do is to store the electric charge. When there is light, you fix it there, they will store the charge there. You are not using it as at that time, but it's being stored. Unlike your bulb, when there is light, the bulb will on. Then when there is no light, the bulb will not be able to give you light. So this one will store the charge. When the light is off, you can on it and it begins to work. That's what like you see solar power or panel, solar engine, or so many others. Even I give example of your touch light. We are not seeing some radios that use capacitors to function. You store energy in them while there's no light, or when there's no NEPA, you can now on them and be using them. You do not put the battery, you use that. That is the work of that is the capacitor. We look at the resistor and capacitor here. These are resistors, you see. This is capacitor. Some of these things, when you have problem with your television, for example, you are watching TV, you just hear, boom, a sound will just come out. And something may be smelling somehow. When you take it to the thing will not work again. The TV will stop or the radio will stop. When you take it to the mechanic or electrician, we tell you that the capacitor is blown. Or the IC. If it's the IC, it will smell somehow. Capacitor blows will give you a sound. You know that it is capacitor that is destroyed in that TV. If you are not knowledgeable, you are not a technologist, you will go there and spend 5,000 naira. But if you know these things I'm telling you, that the capacitor has a sound, you know, that will make you to detect that it is capacitor that is bad in that TV or the radio. Once you hear that sound, or your people tells you that this high, what happened? They will just have the sound somehow, or a little smell from, you will know the particular problem, then you troubleshoot little. You don't even need to do too much of troubleshooting. You already have registered or have acknowledged the problem. Then you need to just fix your little instrument. Then you remove your capacitor. You see that it is blown. You just buy one and fix it, melt it with the soldering iron and other things I've talked about before. This is resistor, this is capacitor. Resistor, capacitor. These are the two of them that we're talking about. Then we also need to talk about the integrated circuit and circuit board. These are the last we need to look at for your weak farm. We know that the integrated circuit is an abbreviation for it's called IC. It is found in electronics also, like the computer or calculator. It does many functions. It's just like the resistor and the capacitor. That's why I call it IC. I've just discussed about the IC in the process of explaining, or in course of explaining the capacitor and the resistor. That it blows or it melts and you begin to feel, it looks like the resistor this way. It looks like the resistor, but it melts and you begin to feel the order. That is for the IC. Then the circuit board contains the circuit arrangement. That is the board, from where you hear the board. That where you put this, put this, put this, put this. That's the arrangement or the device, the way the devices are connected. With inscription, when we say inscription, the person that manufactured it has a way it wants these things to be arranged. Like D stands for diode. When you see D, you know that this is diode. R1 means resistor 1. Resistors could be 1, 2, 3, 4, and it could be on different ohms. 4 ohm, 5 ohm, 2 ohm, and as the case may be. Then C1 means capacitor 1. Then IC means integrated circuit. That's the IC. This is where it should be placed. That's what we mean by circuit board. It contains them with different inscription, or with the inscription, the way they should be placed. That is what we mean by the circuit board. We will recall that at the beginning of our class, we talked about the triode, We said it has 3 electrodes. That is the anode that receives the electron, cathode that emits or gives, and then the grid that controls the flow. We talked about the capacitor. We talked about the resistor. We said the capacitor stores charges. You cannot use the device when there is no AC. That's alternating current, the one you call NEPA, up NEPA, all right. Then we also talk about the resistor, the one that opposes the flow of current. We've talked about the integrated circuit IC and then the circuit board. Lastly, we said the circuit board is the one that contains the arrangement of the devices with their inscription. That is the way they should be placed. Always check your portal for your assignment. Thank you very much. Till we meet again, God bless you.